All right, so we ready? All right. How many IAEI members do we have in the audience? Got two. I want to tell you about a great organization before I get started, International Association of Electrical Inspectors. As engineers, as design engineers, we need to know our inspectors, our contractors, et cetera. Great organization to get educated on things like what we're going to talk about today. So I just wanted to let you know, IAEI, if you want to learn more about that organization, let me know. All right, so we're going to talk 2023 code changes. My name is Thomas Dimitrovich. I'm Director of Codes and Standards for Eaton. I have global responsibilities for Eaton codes and standards, and I try to help our product lines understand the latest and greatest when it comes to the National Electrical Code and standards for product standards, and I work to build relationships to try to help people understand the proper use and application of our products. I sit on Code Making Panel 2 and 10. So panel 2 covers Article 210, Article 220, 210's branch circuits, 220's load calculations. Panel 10 is your overcurrent panel, code making panel, which is your Article 240, 235, 215, 225, 242, I think it is for surge, and some stuff in the annex and definitions. So I don't speak on behalf of NFPA. I don't speak on behalf of anybody other than this guy, because it starts up here, it comes out here, but I really mean it from the heart, so sometimes I'll say things I probably shouldn't say, but I will. In any case, I'll give you a little bit of the background on some of the code changes that you're going to see in the 2023 code cycle. There are code-wide changes. There are changes in the NEC that originate from things like task groups. Right now, we've got various task groups working on 2026 National Electrical Code. And out of those task groups, we get public inputs that have an impact code-wide. You'll see new articles, you'll see deleted articles, you'll see technical subjects like we're going to talk medium voltage changes and reorganization of the NEC all occurs because task groups get together and try to solve problems, right? Either code interpretation, ease of use of the code. The other code-wide changes that you'll see originate from what we call the style manual. The style manual tells us how the code book is organized, how to read the code book, how to apply the code book. The style manual tells you what is permitted from a language perspective, what's not permitted. We try to get rid of ambiguous and vague language, right? And the style manual helps drive that. So one of the changes that the style manual drove was we moved all terms and their definitions to the front of the book in Article 100. So if you're used to going into Dot 2, which was the designated area for definitions, for terms, it's now all in Article 100. So Article 100 has all of your terms, all your definitions, and there are over 800 of those little puppies in there. So finding your term may be a little difficult, but they tried to do things for ease of use and organizing them, and organizing all the terms. So we had multiple definitions, multiple terms, same term, multiple definitions. And they tried to consolidate that, and where they couldn't, they left them both there. So that's all there is to it. And I will say that the way it's organized, you're going to look for, in some cases, a term that only applies to an article in the NEC. Will tell you in brackets, in parens, where they call that. They'll tell you the code making, the article, like for example, if you see a term in there for something related to marinas, you might see 555 in parens. That tells you that that term only applies to Article 555. Okay, don't apply it anywhere else. It'll also tell you if it's extracted text, if you see brackets, like little square brackets, and they'll tell you, like, for example, for talking marinas, 303, and then it'll be a comma, and they say 3.3.3. That'll be NFPA 303, section 3.3.3. That language, when it's in brackets like that throughout the code, is extracted text. That means it's the exact same definition that's in that document. And if you're looking that term up, and you see that extracted text, and you see another NFPA document, I would ask you to go look at that document, because if you're reading something and trying to apply the code in an application where you're seeing extracted text from another document, there's a very good chance that the requirements in that other document apply to whatever it is that you're working on. So be mindful of that. Now, when we moved everything from .2 to Article 100, we opened up .2s across many articles in the NEC that used it for definitions. So what we did there was we basically allocated .2 to reconditioned equipment. So if you're familiar with the changes over the last couple cycles in the NEC, there was a focus on reconditioned equipment, on what you can and cannot recondition, and then also, if you do recondition it, what are some of the rules that you need to follow? And it's all, in my opinion, it's all about transparency. If you recondition a product, we want you to put your name on it because you own it. Not whoever, and it's not HP anymore. If you take that computer apart and you put it all back together again, yeah, you have the shell of an HP computer, but it's no longer HP, it's now yours, right? Same thing with electrical distribution equipment. If you recondition a switchgear, a power circuit breaker, whatever it is, we want your name on it, and you've got to remove the UL label or make it unreadable. That was a change that we made in this cycle for the motor guys out there who recondition or rewind motors all the time. Their UL, their label for the listing mark is on the motor nameplate. They did not want to remove the motor nameplate, so we just made it so you had to obliterate it and you can leave the nameplate on there. So, but be mindful that every section that pretty much, so I highlighted a few that didn't follow the rules, and the reason they didn't, and it's not a rule, it's sort of an unwritten thing. Right, when we did the .2s, it was sort of like a gentleman's agreement where you say, okay guys and gals, we're going to just use the .2 for a reconditioned. And some panels did it, some panels did not. And the reason is because if they did, it would probably renumber the entire article, and they didn't want to go that far. But those are all of your sections. So if you're looking in 430 for motors, 422 should be up there too. It's not actually for wiring devices, but you got Article 700 for your transfer switches. In there will either tell you you can or cannot recondition a product. All right, medium, new and deleted, so medium voltage was another focus from the, there was a medium voltage task group. A gentleman by the name of Robert Osborne chaired that with Underwriters Laboratories. And the group was looking at the medium voltage requirements. The challenge, the problem that we have is there are many medium voltage applications that are governed by the NEC. When do I know it's governed by the NEC? How about this? When do I know it's not governed by the NEC? When it's under control of the utilities, right, correct. But there are a lot of medium voltage applications that are owned by the owner. And unfortunately, there's a lot of people who don't follow the NEC. And then some of the comments you'll get is they'll say, well, the NEC doesn't have requirements. Well, they're in there. So what the task group did was they said, in this first draft, in this first edition for the medium voltage changes, and there's more to come, they simply moved all of the medium voltage requirements into their own articles. So you'll see some articles that have been deleted. You'll see some new articles. These new articles, 235, began in panel 2. We moved all of article, so in 210, we had like 2 sections that were addressing medium voltage applications. But in reality, everything in 210 for branch circuits applies to medium voltage applications. So we moved a lot of the 210 requirements into 235. And then panel 10 did the same thing for 230 for services, 225 for outdoor feeders and outdoor branch circuits. So you got 210, 215 for feeders in there. You have 225 and 230 all in Article 235. Branch circuits, feeders, services over 1,000 volts. So that's your medium voltage home. And quite frankly, if you are worried about what are the changes, technical changes didn't occur this cycle. All they did was move. They couldn't make technical changes because it was in the second draft. And it was just, you can't introduce new material. 245 is your overcurrent protection. So they took the contents of 240 that applied to medium voltage and moved it to 245. 305 for general requirements for wiring methods, 315, 395, 495. So you might see a trend, and the original thought was, hey, we'll just end all of the medium voltage articles with a 5, and that'll be an indicator that it's medium voltage. Well, 215 sort of put a kibosh on that, but in any case, for the most part, if it ends in a 5, there's a good chance it's medium voltage requirements. Now, when you see deleted articles, if you're familiar with some of these articles and you say, wow, the requirements are gone, not necessarily. In many cases, they simply moved them, the requirements, into another article, or they just said it wasn't applicable and they just deleted it, like in the low voltage DC, but below 50 volts, they didn't see a need for it. But on most of the case, like the 311, they moved it to 315, 399 moved it to 395, and 490, they moved it to 495. And again, if I would hazard a guess, the technical changes in those articles are minimal, if any, because the primary focus was to just line up the medium voltage articles in the code. So it's getting some love. The medium voltage applications, we're recognizing there are some technical issues with the requirements. Medium voltage equipment, you don't do 1.25 times the load. It's not 80% rated equipment. It's 100% rated equipment. Yet the NEC sort of implied that it was 80%. So we're trying to add that clarity in the code. How many people here deal with medium voltage applications? All right, my ask is for you all to take a look at the medium voltage requirements in the NEC. If you see things that don't make sense, your familiarity with the NEC that deals with utilities is probably better than some of these individuals who are even on the code panel. So my ask would be, take a look at those requirements. If you see something that doesn't look right, doesn't smell right, it may not be right, if you can bring it to our attention, I'd really appreciate that. And we can help you either formulate a public input, or if you say, look, I don't want to do a public input, but this just isn't right, then let me know and we'll try to fix that in the next cycle. Public inputs aren't due until, I think it's August or September of this year, so we're working on 2026. These are new articles so these are 355 instrumentation cable tray. You've got drilling rig cable, type P, insulated bus pipe. You got flexible bus systems. Oh, you can't forget about cannabis, right? We all have to, I'm not sure if, there's a lot of there's more legal grow facilities going in the United States these days. Cables for power limited circuits. Power limited in class 4, there's a new technology on the market that drove this. There's a company out of California that is doing what they call pulsed DC power. They're trying to use more power over small conductors, right? And they want to make it a chapter 8 wiring method, because chapter 8 is not a part of, it's a part of the code book, but it doesn't pull in chapters 1 through 7. So, and it's not inspected typically. So they're putting a lot of power over smaller conductors through this, what they call a pulsed DC. And they were listing it to data and communications standards. So UL got a whiff of that, and they said, and the industry got a whiff of this, and they said, we really need to formalize this, because if it is a good technology coming to the market, we don't want a failure. We don't want to give something a bad flavor if it is a good solution. So we basically UL created a standard for it. They did some research, and we created some requirements and new definitions in the NEC. So you'll see, take a look at 726 for pulsed power. I think the focus of that technology is around powering LED lights, because it's DC. I mean, if you think about it, everything we have that's plugged in got to go through a converter, right? And there's a lot of work going on low voltage DC distribution in the code and in standards. So it's another thing to keep your eye on the ball with regard to application of power distributions and how it may change in the future. All right, then Article 510 was deleted. They said, we didn't need it. And 720 for less than 50 volts, they said, it's already covered elsewhere. So some of the requirements in these articles were covered elsewhere. Article 512 is your cannabis. Can't forget about that. And these are all the medium voltage applications, which I just went over. I'm not going to go over it again. We already talked about medium voltage, 235, et cetera. So all of that. This is what you'll see now. So now Article 210, since we stripped out medium voltage, we had to change the scope of each of the articles. So now Article 210 just says not over 1,000 volts AC or 1,500 volts DC nominal. If you want some, the requirements for over 1,000 volts AC and 1,500 volts DC, then you go to where? 235. And why? And so the medium voltage, we established two lines in the sand, 1,000 amps or 1,000 volts for AC and 1,500 volts for DC. That was driven by IEEE standards and international standards. They established that 1,500 volts for DC as that line in the sand for medium voltage. And what drove the 1,000 volts up over the last couple cycles was your photovoltaic applications, PV. They got rid of the transformer in your inverters, lightened them up. They removed the losses. But when you when you take a transformer out of the picture and you need voltage, they had to raise the voltages in those applications. So, and the voltages in PV are still going up and up. I don't think they've settled out yet. There's your 235. So part 1, general, branch circuits, feeders, outside branch circuits and feeders, and then part 5 is services. So again, when you look at this article, it's existing language. And in fact, if you look at branch circuits, I chuckled a little bit because we simply moved stuff out of 210. So you'll see things in there about branch circuits for appliances, medium voltage appliances, which I thought was, boy, that's kind of ridiculous. But we couldn't make any technical changes. So we're going to clean it up. We're going to clean it up this next cycle. All right, surge. We all love surge. Power quality is important, right? So last cycle, what did we do with surge? We put a mandate. So surge has seen a lot of changes over the years. We had requirements in Article 700, 708 around special conditions for surge protection. Article 700, any panel board or switchboard in a life safety system, an emergency system, has to have surge installed. In Article 708, I think that's the first place it was put in, because I was trying to find a justification, and I couldn't find a justification for surge in Article 708 systems, at least substantiation for the public input, because it was created, it was put in when Article 708 was created itself. So, and that happened because of 911. That was for your national security reasons. So Article 708 was, I would argue, the first location, and then we did 700. But then if you look at all these different special equipment, but from elevator control panels and other applications, industrial control panels, you're seeing more and more surge requirements. The big change that happened last cycle was dwelling units. We put it in for dwelling unit service entrance. And then this cycle, what we had to clean up, there was a realization on panel 10 that sometimes, we had it in Article 230 for services, for dwelling units. But then we said, well, wait a second, what happens if the service is out at the road? Because in many cases, there's a service is out at the road, and then we have what? An outside feeder that comes to the structure. We don't want surge out at the road. We want surge on the structure, right? And then we said, well, we can't make it required both locations. So we modified and we added some language in 215 and in 225 that recognize those applications. And I guess the bottom line with surge from an industrial and a commercial, regardless application, you want those lead lengths very, very short. And you want the surge as close to the structure as your distribution as possible. And you can't forget that surges come from out there, but they can also be generated from inside. So you may need surge at various levels. I believe IEEE tells you to have multiple levels of surge protection, from the surge strip that you might have on the appliance to knock it down that final level, all the ways up through the system. And I know Dan Carnevale has a great demonstration as part of our experience center, where he demonstrates the lead length and the impact of every inch of lead length that you add between the surge device and the bus makes a big difference in let through, right? I can sell you the product, but if you put it 10 feet away, I got the money and you don't have no value. So you want to make sure we apply surge products correctly. And I tried to get language in the code that said, a minimum lead length, but I failed there. I got a recognition that lead length matters in regard to surge installations, but I did not achieve a maximum length of conductor for connecting the surge. All right, so we expanded surge and again, 215, 225, and 230, and we went beyond dwelling units to other commercial type of facilities. We went to dormitory units, guest rooms and guest suites of hotels and motels, and then nursing homes and limited care facilities used exclusively as patient sleeping rooms. Anybody do healthcare in the room? All right, so in the healthcare applications, you know, you might say, some healthcare people might say, wait a second, you're stepping on the toes of Article 517 with regard to nursing homes and limited care facilities, but if you look at the exceptions, there is a section in Article 517 that says the branch circuit requirements are not covered in 517 for those applications. So that language is exactly extracted basic text from Article 517, that specific section. And we already talked about the 215 and 225, and we reorganized 230. So here's how we did it. 230-67. You have surge protective device requirements, you have the location, you have the type, the replacement. So we addressed that if you update a service, and say it was from the 50s, we want you to put surge in for the new service. Also the feeders, etc. And the type, replacement, and the ratings. One of the big complaints that we got was that you put surge requirements in, but you didn't tell me what the rating needs to be, right? Because you can buy a surge device and it may not produce and do what you think it's going to do just because of how it's constructed and what some of the parameters are. So, dwelling units, there's the 4 areas that we added. And then this was in 230, so we said, and we said if you, in 215 or 225, we said if you have it at the location, at the structure, then you don't need to put it in 230.6, meet 230.67. We want it to be an integral part of the service equipment or immediately adjacent thereto. And we had there's the exception if it's located at each next level distribution. So basically I could put surge there in an application, or if I put it at all the next level distribution, then I don't need it there, right? And that's like good for your like multi-family dwelling units and your larger installations. But now the other application that we saw was in some cases off of that meter stack, they were coming off with a breaker and going to an HVAC unit outside. And they said, well, do I need to have it on that HVAC unit, or still do I need to put it in my service equipment? If you feed anything, it says in the code, all downstream equipment, whether it be an HVAC unit or panel boards or whatever you're feeding from that structure, from that service, you have to have it at all the locations downstream. So if you have something on the outside and you're taking a breaker off of that to feed, like say an HVAC unit, you either have to have surge in that service or down there at the HVAC unit to be complete and meet the code. Type 1 or Type 2, you can put a Type 1 on the line side of the service over current device or on the load side of the service over current device. You can only put a Type 2 on the load side of the service over current device. So this just gives you an idea, this just tells you what is applicable. You're only going to be using a Type 1 or a Type 2. The rest of the other types are used like for industrial control panels and things like that. There's your replacement. If you replace it, then you have to adhere to the requirements of 230. And we put this same language in 215 and 225 as well. And I have a feeling that in next cycle, we're going to clean up the rest of the surge locations as well. So this is just a taste of what's going to probably come for industrial control panels and Article 700 systems, et cetera. It's just a flavor for what you're probably going to see over there. Because here's what happens. We make a change in Chapter 2 and one cycle, and then someone scratches their head and says, well, wait a second. I have a good friend of mine who'll say, Thomas, how does that little electron know that it's in a dwelling unit and it's not in an Article 700 system? And he's absolutely right. So then all of a sudden you get public inputs, and then we move those requirements. So I'm sure you're going to see probably especially things around ratings as well, for that's like sort of the performance. So the rating that we put, and this was relatively controversial actually. It was appealed. There was arguments at the floor of the annual meeting. The nominal discharge current rating of not less than 10,000 amps, I liken it to I liken this to like the treads on the, or like you're going to buy a roof, right? You're going to put shingle on the roof. You can get a 20-year shingle. You can get a 30-year shingle. You can get a 100-year shingle. You can put a metal roof on, last forever, right? So this is sort of the way they test the devices. They'll hit it with surges, and it has to last based upon, it has to survive a number of hits of certain magnitudes. So that's what this rating does, and it's more of a performance from a longevity. The argument being that, look, when a surge device fails, or when it gives its life for your products, right? When it finally expels its final electron, what happens? You get a little LED that says, I'm dead, right? That's it. So it doesn't turn the circuit off like a circuit breaker does. It just turns a little LED, and you have to go down and actually look for it. So we want these things to last as long as we can, and that's what that rating is all about. We did the same thing in 210.8. You'll see the same structure, same language, load side of the feeder, it contains branch circuit. So this is similar language, basically the same language that we saw in 225 and in 230. So same structure, and my only reason, there's the language I got in for the lead lengths. I argued that one. I argued very passionately at the table too, but it was online. So this cycle was all virtual. So there's only so much emphasis you can put when you're just a voice on the other side of the phone. All right, energy management systems. We all love energy management systems, right? So an energy management system, they came up with a definition, and I absolutely hate the definition. I think it needs a lot of work, in my opinion. It says a system consisting of any of the following: a monitor, communication equipment, a controller, a timer, or other devices that monitor and or controls an electrical load or a power production storage source. So I have a phone. On my phone, I can look at how much energy my outside lights and my inside lights are using at the house, and I can turn them on and off. Drives my wife crazy when I'm remote and I demonstrate it to somebody. But technically, I meet the definition because I monitor. I mean, all I have to do is monitor. And they call it an energy management system. So, but the way they use the term elsewhere in the code, in Article 750, 220, 705, 625, a very important aspect of an energy management system is that it has to control the loads. And how we leverage the energy management systems in the NEC is we'll tell you, you can size feeders, you can size your service based upon what these energy management systems limit your energy usage to via load control. An important aspect of this is in Article 705 for interconnected systems. The challenge in a 705 system, if I have photovoltaics and I'm coming into a panel board on the load side of the service over current device, not on the line side, but on the load side, I'm going to connect it through a breaker, which hopefully will be reverse power fed capability, right? And what do I have to do to the bus? I've got to consider now I have two sources, and I can put more load on this panel board, right? If my panel board's rated for 200 amps, and I have a 200 amp main, I can tell you I'm not going to get more than 200 amps long enough for me to overload and heat up that bus bar, right? But if I have my main at 200 amps and I have a photovoltaic system connected in, now I can put more than 200 amps worth of load and not trip an overcurrent device, and now my bus is overloaded. So in the photovoltaic world, in Article 705, any interconnected system, they're basically saying, look, if you have an energy management system and it limits the amount of energy that it can put into the system, then you can size your panel board based upon the set point of the energy management system. Now that's a little scary because a lot of these energy management systems, if you have to do any interaction with them, what happens? You install it, and you get a pay raise and a promotion because you saved the company so much money, and then they give you a promotion and you move to another facility and the new person comes in and says, I don't know anything about it, just turn it off, right? They don't want that. They want to make sure that this is a safety-related piece of equipment now, because now I'm sizing my power distribution system based upon that set point. And we're also seeing it in electric vehicle chargers. So electric vehicles, you know what's going on in the electrical vehicle industry? You know, you bought this $80,000 hunk of burning love that's sitting in the driveway, and it's got this big battery, and you want to power the house with it, right? Why buy a generator when I got my F-150 out there or my Chevy or whatever? And I just paid 80 grand for. So now they're saying, look, we can power the house. And if you do that, you need to make sure that you are doing an energy management, have an energy management system in place so that you don't overload the system, overload the vehicle, et cetera. So we're relying more and more on energy management systems. They're used in these articles, in these sections, and I think it needs a little bit more love, but I think it'll get there over, you know, the code book is like a fine wine. It gets better with time based on public inputs. So you get engaged with the NEC as you see things. If you see applications that aren't covered or need help, think about some public inputs or raise the idea, give one of us a call, and we'll help you formulate a public input for next cycle. There's your 705.13, an energy management system in accordance with 750. 750 is for energy, it's the title of the whole article is energy management systems, permitted to limit current and loading on the bus bars and conductors supplied by the output of one or more interconnected electric power production or energy storage sources. So we're relying on this system to size our equipment, and it better work. So the standards are addressing this. I think there's probably some opportunity for the UL standards to take a look at the listing requirements around these energy management systems and make sure that they're going to perform the way we need them to perform. They have to be listed as a type of EMS. A listed power control system is a type of EMS that is capable of monitoring multiple sources, et cetera. So, and what you're seeing on the electrical vehicle charger world is the management of the power distribution, where you have multiple vehicles can plug in, and then they'll manage the power for charging those vehicles. So you don't have to size the service for the electric vehicle chargers bigger than the service for the structure. 110.3, so what do we do there? I'll tell you what we did there. We modified cybersecurity. We added, so cybersecurity is now in the NEC, and it's a challenge. It's controversial. Some people will argue it shouldn't belong in the NEC. Some people will say it belongs in the NEC because that's the hook. That's the document that's enforced and adopted by states. And so if you don't have it in the NEC, it becomes like a 70E document, which is only enforced after the fact if you have a problem. So in any case, we have a requirement in list item 8 that says cybersecurity for network-connected life safety equipment to address its ability to withstand unauthorized updates and malicious attacks while continuing to perform its intended safety functionality. This is what an electrical inspector is supposed to review your installation in regard to, right? Which is very, very vague. Okay, what is a life safety system? If you would assume life safety system would be what? Article 700. Right? I would go, hey, I'm going to go back to 700. There's no requirements in Article 700 that were accepted by Panel 13 around cybersecurity. So you say, well, I don't have any requirements there. So we have requirements in Article 240 for overcurrent protection devices that are network connected that I can control the set points. We put it in Article 708, and I'll show you that language, which was, again, controversial, probably not applicable for the NEC. So this whole topic is in its infancy with regard to the NEC. It's already in NFPA 72 and many other NFPA documents. The general concern is we don't want someone to be able to take out a power distribution system maliciously because it's connected to the network. Now, if you talk to a cybersecurity expert, they'll tell you, well, that doesn't address the internal threat. Right? The bad actors don't have to be outside, they can also be inside. So, but in any case, it's getting recognition. There's a lot to be done on cybersecurity. There's two philosophies. There's a component focus. You know, UL's out there says, hey, we got a standard, we can list our product to this standard, and then there are people that say, well, wait a second, I don't need that. I'm just going to do a cybersecurity assessment because it's not just the product that makes the difference. I can buy an Apple computer and say, look, okay, Apple computers don't get hacked as much, all right, so I'm good there. I can put some virus scan on it and say, okay, this is great. But then, you know, next month, all of a sudden, I've had 5 updates to the virus scan for the virus software, and I can still be vulnerable, right? So it's not a set it and forget it mentality. It's a continuous process, which the NEC is an installation requirement, right? We're inspectors The inspector guys will say, I'm an inspector, not expector. I can't tell you what's going to happen in the future. So we got some requirements, but that's the basic gist of the philosophies. You have two philosophies. I want listed product, and the second philosophy is we want a system analysis, and we want a cybersecurity assessment, which I love the language. A circuit breaker that can be adjusted remotely to modify the adjusting means shall be permitted to have an ampere rating. So this is your adjustant, 240.6. I can adjust the amp rating of the device, and then I can connect it to the internet, right? And I can connect it to the network. And it says that you can do that if you connect it through a networked interface that complies with one of the following. A circuit breaker's associated software for adjusting settings are identified as being evaluated for cybersecurity. That's a listing mark, okay? And then the other is a cybersecurity assessment of the network is completed. So you install your system, and you get these circuit breakers, and you do a cybersecurity assessment, and you hire our guys to come out and do it. And Dan Carnevale comes out to site. He walks through everywhere, and he says, all right, guys, you know, man, you're in bad shape. You know, not only are you hackable, but you've been hacked 4 times since I've been here. And here's my assessment. You get red, 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 red. This is terrible, terrible, terrible. And I give you that report, and I met the language of the code. I did a cybersecurity assessment. Okay, so I think this needs a little bit of love, a little bit of work to put some performance parameters around it that says a cybersecurity assessment that meets X, Y, and Z performance would be good, or something of that nature. My point is, it's in its infancy, but it is there. It's in Article 240. So you take circuit breakers, you put them on a network. You can view them from your iPhone, from your Android phone, whatever phone that you're using. And you can access your system from your computer and your desk. All these great things you can do. You can change set points. You can do a coordination study. All these great things. You're going to have to do either have all of those breakers listed or do a cybersecurity assessment. Probably everybody's going to migrate to the cybersecurity assessment. And you should have a program in place anyway that is ongoing, because cybersecurity threats don't stop just because you have an assessment. There are some references to standards. There's 2900 for cybersecurity. That's what we would list products to. And then there's NIST frameworks and et cetera. So there's a lot of reference materials out there that we can use to harden your system. There's your 240.6D, the ISA. So these are, again, just the informational notes. There's your 240. Remotely accessible. Again, cybersecurity is a specialized field. So they added a bunch of information. And this was controversial. You know, the Ciscos of the world and others were like, look, and they're technically right. Okay, their point was that, look, you have a requirement in the National Electrical Code that is defunct the moment you do the assessment. And oh, by the way, I can do an assessment, and it tells you you're very vulnerable and you didn't get anything done. So, but it will get better. It's like a fine wine. There's your 708. Now here's the issue with this one. Okay, you'll see that, again, the two philosophies are here. Connected through a network interface, you have A, being evaluated for cybersecurity, B, doing the assessment. But the problem in 708 was this language right here, which is what failed it at the panel meeting. The National Electrical Code is an installation requirement. We don't look at it every 5 years. 70E tells us we need to do our systems analysis studies every 5 years because that's a part of your work plan, your safety plan. But the NEC, that doesn't necessarily belong in the NEC. Cybersecurity assessments shall be conducted when the system configuration changes at not more than 5-year intervals. And the point of a lot of the cybersecurity people is that it's not when system changes. It's an issue regardless of your system may not change at all, and you still have a cybersecurity threat. All right. Arc flash hazards, okay, 110.16. Remember these, right? 110.16, there you had your arc flash hazard. This is your arc flash label based on 70E. This is an IEEE 1584. That's just a, hey, it's dangerous. This has been in the code for a while, and this cycle, we expanded the marking requirement in 110.16b beyond 1,200 amps. We moved it to 1,000, and then we also said feeder supplied equipment. So it's not just services anymore. So we expanded that to feeder supplied equipment. If you do arc flash studies, who does arc flash studies? I love all of you. All right, so you're going to be doing more of that for anything that's 1,000 amps and above. whether it's a service or a feeder supplied equipment. There's where we took the 1,000 and in accordance with acceptable industry practice. So what we removed out of here, remember, we had the voltage, we had the clearing time of the service overcurrent device, all that jazz. That lined up with 70E's PPE category method. But when you're at the service, you can't use the category method at the service because your protecting overcurrent device is on the utility. And if you dressed based upon the PPE category method, you would be underdressed for that application. We know service equipment is very high incident energy. So be mindful of that. Those are your type of your labels. And this is both of these would be in accordance with 70E, whether you do an analysis method or you use a PPE category method. Both of those are accepted by 70E. And remember, your protecting overcurrent device is upstream. You're doing the work downstream and your label is down there, but your clearing time is based upon the upstream overcurrent protected device. So 1,000 amps and larger, that equipment would have to be labeled. Reconditioned equipment, I already talked about that. I'm not gonna, we just added more clarity on reconditioned equipment. Again, more clarity on marking requirements. I already talked about the motors. Servicing, we added the definition for servicing because people said, look, if I'm not reconditioning, remember, if I take a product and I take it from a non-working state to a working state, I'm reconditioning it, okay? But if I take it from a non-working state to a working state and I buy products, I buy components with instructions from the manufacturer, now I'm servicing it. Okay, and we added the definition of servicing and what that means. So you're following instructions and you're servicing equipment. This helps make sure that if you remember, the confusion is the definitions are critical because if I meet the definition, now I got to follow the requirements. So because we added the definition of servicing, you should be sure that we will have requirements for servicing when you are servicing, where you get the parts, what are acceptable parts, and who can perform the servicing. And that's in 110.17. And you can look that 110.17 up as you get through there. So we addressed servicing. This is a big one, 110.26. All open doors. So remember, we took the large equipment. We made changes in large equipment. We said if it adds up to 1,200 amps and above, then you need to have two entrances and egresses from that room, not just 1,200 amps, right? So if it adds up to 1,200 amps. And we also added language that says the doors, open doors, cannot impede egress to or from a working space. And what they did was they took that language and they moved it to the parent text, both for low voltage and medium voltage. So now if you have a hallway and you have equipment on either side of that hallway and it says simultaneously opening doors, simultaneously open equipment doors. So if I open the doors on both sides of the hallway, I need at least 24 inches of egress space. If your hallway's short or your hallway's wide and your equipment is deep and you open both sets of doors and you don't have 24 inches, you have an issue with egress. How are we on time? 5? I got a little bit more? Okay. All right. 210.8. Here's what we did in 210.8. I won't cover dwelling units. Other than dwelling units, kitchens. We just split out kitchens and areas with sinks. Here's what we recognized. The hazard is not the receptacle. In 210.8, we do all of our measurements off of a receptacle. Why? Because inspectors can walk into a rough-in or into a for final inspection, they can see the receptacles, they can do the measurements. But we realized the hazard is not the receptacle, the hazard is the appliance. It's what's plugged into the receptacle. So we made a change in 210.8A for dwelling units. It said if it's in a kitchen, I don't care. If it's in a kitchen and it's plugged in, you GFCI protect it. And if it's cord and plug connected, we added a 210.8D. But for other than dwelling units, we added a little bit different language. We said, look, if your appliance is within 6 foot of the sink, it's a permanently fixed or stationary appliance. If it is within 6 feet of the sink, not the receptacle, then you need to GFCI protect it. Okay, so we added that realizing that it's the appliance that's the hazard, not the receptacle. We fixed the indoor damper. Aquariums, bait wells, and similar. If you do aquariums, if you do one of those bait shops, you're going to be GFCI protected. You're probably already doing it anyway. Okay, I already talked about that. There's your specific appliances. We expanded this. The panel, there were a few people on the code panel that did not want to expand to appliances. And one of those individuals reached out to the Consumer Product Safety Commission and said, show me the numbers. And they taught that individual how to fish, I say, and he did his own homework. So the expansion that you see with appliances in 210.8d are because of his research. So in 210.8d, it's whether it's cord or plug connected or hardwired, doesn't matter. 150 volts less to ground, 60 amps or less, single or three-phase. We added electric ranges, wall-mounted ovens, counter-mounted cooking units, clothes dryers, and microwave ovens. All of those have body counts associated with the Consumer Product Safety Commission. And most of them are from workers, people. What do? What's justified energized work? Maintenance, right? If you're troubleshooting a circuit, you've got to have it on. And these appliances were killing people because they're troubleshooting. There's a new special purpose. So if you do, what do you call it, hotels, place like this, and you have a swimming pool, and it's a 480 volt pool pump motor, or if you have a very big home and you've got a 480 volt pool pump motor, you're going to need what they call a special purpose GFCI. Special purpose GFCI doesn't trip at 4 to 6 milliamps. It acts off of the principles from the European standards. So European standards use 30 milliamps. In the US, we use 4 to 6. Do you know why? Why is the equivalent of GFCI in Europe 30 milliamps? Anybody know?
Because they do multiple circuits. So that one GFCI that covers 8 circuits and the cumulative adds up.
But how can it protect you from shock at 30 milliamps? Oh, it doesn't. All right, I'll tell you that they do that, and I just learned that. I was looking at some circuits this past week. 30 milliamps in Europe is because they worry about defib. We go into defib around 40 milliamps. In the United States, we care about let-go thresholds. Dalziel, all of Dalziel's research, right? Dalziel, took all of those people who needed beer money, right? And they said, hey, let's put some current, see if you can hold on to this rod, right? And oh, you know what? It's not just men. We got to get some women too. And then if you go back to the 30s, they tested children to determine their resistance values of their bodies. So a lot of what we know now about let go is because of the sins of our fathers who were doing the bad things, and now we know what 4 to 6 milliamps is about, the place where you can't let go of a conductor. In Europe, they don't care about the let go, they worry about the defib, okay? And the 30 milliamps is because of those accumulated leakage currents, right? And in some cases, some countries use 300 milliamps at the main. So they put a 300 milliamps at the main on a structure, and then they go 30 milliamps on those branch circuits. So the special purpose GFCI works off of that same principle, and what they're doing with a special purpose is they are trying to control the voltage across the body, and they have assured grounding paths. There's software in there that makes sure that the equipment grounding conductor has to be a certain size, and they're trying to control the voltage across the body so that they know how much current will flow through the body if you come in contact. But these are applicable to greater than 120 volts. They're up in the 480 volt systems. So there's peppered requirements in swimming pools and in, I believe, RV parks too. The same barriers that we have on service entrance equipment, 230, we put barriers on 230 because of why? What's the 2 elements of risk? 2 elements of risk, come on. I'll give you one, likelihood. The likelihood of an event happening, what's the other?
Incident energy.
Incident energy is a type of hazard. It's the severity. It's likelihood and severity, right? I'm going to get on a plane tonight to go home. The likelihood of the plane going down is pretty low. What's the severity? Pretty high. But we say the risk is low of getting on a plane as opposed to driving in a car, even though the severity in a plane crash is much higher than an accident in a car. So we could control or we can manage risk. And Article 215.15, the secondary of transformers, what do we know about the first panel board on the secondary of every transformer? Where's the incident energy is dependent upon what overcurrent device? First panel board on the secondary of a transformer, what is the overcurrent device that I rely on for my incident energy? Primary. And how do I pick that primary? Am I picking it if I have a 300 amp full load amp? Do I put a 300 amp breaker on it? No, right? I could go up to 250% of 300 amps. My instantaneous is moving further and further to the right. The incident energy on the secondary of every transformer is very high for that reason. So we recognized that and we said, look, if you are feeding a panel board, switchboard, switchgear, or motor control center that are fed from a feeder tap, and a feeder tap is inflated high too, or a transformer, then you have to put barriers to reduce the likelihood of accidentally coming in contact with energized parts. So that device right here, this main overcurrent device on the secondary of the transformer, and if it's a delta Y ground, you always have to land on an overcurrent device for a panel board, especially a panel board. So you're going to have to barrier that line side, and that's really on us, but don't throw away the booties, okay? When we ship a panel board, if it has booties, don't throw it away, because if it's the first panel board on the secondary of a transformer, you need to put a barrier there. And this is why. Look at this. 23.5 calories on the secondary of this transformer. Why? Because it's relying on that device for the clearing time. But if I simply move the overcurrent device out, and maybe I integrate it with the transformer itself, now my incident energy, where the likelihood that I'm going to do justified energized work has gone from 23.5 to 0.34. I'd rather work on 0.34. Actually, I'd rather be on the couch. So anyway, so there's your OCPD, there's your tap conductors, panel boards. That OCPD is sized larger than these tap conductor sizes. So you've inflated the size of the overcurrent device. I've increased the risk because the severity of any working on any of this down here is high. And this is my last one. So selective coordination, emergency side. So how many people selectively do selective coordination studies? Oh man, I love all of you. Excellent. You know, it's beautiful. So all of this on the right-hand side is, say, your Article 700 system, right? 700, 701, 708, anything that's on the load side of that transfer switch and feeding the transfer switch from that generator, that's the emergency side. The big debate has been, panel 13 always gets public inputs and says, well, what about devices 1 and 4 that goes to that transfer switch? Do I have to selectively coordinate 1 and 4? So panel 13 said, no, look, you have to selectively coordinate 7 with 4G and 7 with 4 and 7 with 1, but 4 and 1 are outside of the purview of Article 700 because they're on the normal side. Article 700 can't tell you what to do on the normal side. They can tell you what to do between 7, 4, and 7 and 1, but the onus is on 7, not those other 2. So panel 10 said, you know, we're worried about the reliability, and from a failure mode, from a reliability perspective, transfer switches may not transfer. Generators may not start. So if I can avoid the transfer, then I've increased the reliability of the system. So in 240.11, we now require, when you are feeding a system where the overcurrent devices downstream of that transfer switch have to selectively coordinate with the normal side, which is your Article 700, 701, 708, I've got a list of them, then you have to selectively coordinate the main with the first level overcurrent devices. So the main and the immediately connected branch or feeder breakers. So everything in that top left. You don't have to selectively coordinate down below 2 or down below 3, but you know that if you have a fault down below 2, you'll take out 2 and you won't transfer. If they did not selectively coordinate, you could take device 1 out, which is your main, and now you've forced a transfer needlessly. And what if the transfer doesn't switch? What if the generator doesn't start? Now you're into an emergency mode. So that was the point there. Anywhere that the feeder overcurrent protected devices to be selectively coordinated with a service, basically anywhere you're feeding these types of systems, 620, 645, et cetera, you need to selectively coordinate those devices. Make sense? And that's it. And then the replacement trip units have to be listed. Whew. I didn't think I'd get through all of it, and I probably went over time. Any questions?